In the previous examples, we made it a point for you to find the x or the y value that had a coefficient of 1 or -1. And so you can see here, this is going to help us choose the method that we want to solve the system of equations with. And so you can see that in the first example we had an x that had a coefficient of 1. In the second example we had a y that had a coefficient of -1. And so both of these were easily used for substitution. Now, if we get an example that actually does not have a coefficient of 1 or -1, then what we're going to want to do is we're going to move on to the linear combination method. Now, the linear combination method has been referred to as the elimination method informally in a lot of textbooks, and a lot of teachers use that language. So be aware that if your teacher uses linear combination or elimination, that they basically mean the same thing. And so let's take a look at what we're going to be doing here in linear combination. Basically, if we look at example number 2, we'll follow the steps in example number 2. What we basically are looking to do is to stack these equations on top of each other. But what we're hoping to do is to create a situation where one of the variables, either the x or the y, has an opposite from each other so that we can combine the terms together so that they eliminate each other, and that's where the word elimination comes from. So the very first thing we're going to look to do is to see, can we multiply one of the equations by a value that would end up creating this offsetting value? And so if you look at it, we have 2x and we have a 4x. So I got to think to myself, is there anything I can multiply to 2x that would give me -4x? Because I want it to be the exact opposite of the 4x. And so I can multiply that by -2. Now, here's the thing. It's like the distributive property in a way. If I'm going to multiply the 2x times -2, I have to multiply the entire first equation by -2. And when I do that, I get this new equation. I get -4x plus 8y equals -26. Then I'm just going to rewrite equation 2. And so I'm going to do this in a stacked method. And so basically I'm going to add or subtract up and down. So at this point I'm combining like terms. So if you look at step 2, it says to combine the like terms. So I know that 4x and -4x actually cancel each other out. They give you a 0x. 8y and -5y gives us 3y, and -26 and a +8 gives us -18. So now I simply have this equation 3y equals -18, and I can solve for y. So y equals -6. So I've used this elimination process to come up with my y value. Now the interesting thing about here is this is technically elimination. Once I've got it down to a variable, y equals a certain value, we're actually going to use the substitution process to get on the back end of this. And so you can see here in the third step, we're going to use substitution by taking the -6 from the previous one of y and replacing the y with -6 so that we can come up with our x value. And of course, once I have an x value and a y value, I can set those together as an ordered pair. So that is your brief example on using linear combination, or informally known as elimination method, to come up with the solution for this system of equations. So what I'd like you to do is go ahead and stop right now and work on sample problem number 2, part A and B, and try to figure out how to use the linear combination method to solve these systems of equations. Okay, now we'll take a look at a couple of examples for linear combination. So if you notice right off the bat in part A, we don't have a single coefficient that's 1, and so that's why we're going to take a look at using linear combination in this method. So now I need to look at the individual x's and individual y's and see if there's any way that I could create an opposite coefficient. And so with 2 and -3, I would actually have to multiply something to both parts to create an opposite coefficient. So before I take that route, what I'm really going to want to do is see if I could do it with the y's. And I notice that I have a -6y, and I would simply just need to multiply 3 times 2 to offset that -6. And so what I need to do is I need to multiply the entire second equation times -3. So I'm going to actually multiply this whole thing times 3. Now, I'm just going to simply rewrite the first equation. So that's 2x minus 6y equals 19. And my new equation, my new second equation, will be a result of me multiplying 3 times everything. So that's going to give me negative 9x plus 6y equals to 30. And notice I've taken particular care to keep the x's stacked, the y's stacked, and the equals and the answer stacked. And so now I'm going to combine like terms. So 2 and negative 9 is going to give me negative 7x. The negative 6 and the positive 6y are actually going to cancel each other out. And then I'm going to have 19 and 30, which is going to give me 49. And so if I simply divided both sides by negative 7, I would get x equals to a negative 7. Now, I need to take that negative 7 and substitute that value in for x in either one of the original equations. And so it really doesn't matter which equation you pick in this substitution process. So I'm going to choose the first one. I'm going to say 2 times x, and of course I'm going to replace that x, minus 6y equals 19, and of course in place of x I'm going to put this negative 7 value. And now I will solve this down for y. Okay, now you can see that y equals to a negative 11 halves. And so I need to write this as an ordered pair, so that's negative 7 for my x and negative 11 over 2 for my y. I personally prefer you keep it as an improper fraction. You will need to find out what format your teacher wants the fractions in, either mixed numbers or decimals, but I personally prefer improper fractions. And so you can see our ordered pair that is the solution to this system of equation. It's not a real pretty ordered pair, but it's the correct answer. So let's take a look at part B. Again, part B, I need to identify a place where I can create negative or opposite coefficients. And so right off the bat, if I just multiply 2x times 2, I can get an opposite coefficient. So I'm going to multiply this entire first equation by 2, which is going to give me 4x minus 6y equals to 2. And then of course I'm going to rewrite the first equation, the second equation exactly the way it is. And when I do that, the 4x and the negative 4x cancel each other out. Negative 6y and positive 2y gives me negative 4y, and then 2 and 6 gives me 8. Y is going to equal to negative 2. Again, I simply need to substitute that negative 2 for any of the y's, so I'm just going to rewrite one of these equations, and it does not matter which one, and I'm going to replace that y with negative 2. And now I'll simply solve for the x. And now I have a value for x and I have a value for y, so the solution to my systems of equation will be the ordered pair negative 5 halves and negative 2. Okay, and that was 2 examples of linear combination, or what is sometimes referred to as the elimination process.